Tonight, new evidence in a 13,000-year-old mystery. What killed the American mastodon?
A new discovery by a Miami University professor is giving us some new answers tonight. A News 5's Eric Zarnitz is showing you.
More than picture yourself descending thousands of feet below the ocean's surface, surrounded by nothing but crushing darkness and bone-chilling cold, when suddenly the floodlights of your submarine illuminate something that should not exist. Right there in the pitch-black abyss is a lake. A complete, fully formed lake sitting at the bottom of the sea, with its own shoreline, its own rippling waves, and its own warm, glowing current drifting lazily across its surface. It looks like an invitation, a peaceful oasis in a barren underwater desert. But the moment any creature makes contact with its water, it stops moving forever, its body perfectly preserved in a state of chemical mummification. This is not science fiction. This is the terrifying and astonishing reality of deep-sea brine pools, and understanding how they exist, why they kill, and what they might mean for the search for alien life is one of the most fascinating journeys modern science has ever undertaken. The descent into the deep ocean is a process of total sensory erasure. Red wavelengths of light disappear first, followed by yellow and then green. By the time a research submersible has dropped past 1,000 feet, sunlight has ceased to be a physical reality. At 2,000 and 3,000 feet, the pressure against the hull climbs beyond 1,000 pounds per square inch, and the surrounding environment becomes a featureless gray wasteland of cold, still abyssal mud. This is where the ocean floor typically remains, monotonous, frozen, and empty. But then something extraordinary disrupts the void. The high-powered cameras of a remotely operated vehicle suddenly pick up what appears to be a coastline. There is a dark, defined beach ahead, and beyond it, an unmistakable body of liquid resting inside the ocean itself. The surface of this subterranean lake shimmers, ripples travel across its top, small internal waves break against its banks, and a dense haze hovers just above it, like fog, over a mountain lake at dawn. Every instinct tells the scientist watching from the control room that they are looking at a landscape on dry land, perhaps a canyon lake at dusk. But the instruments tell a completely different story. They are looking at a lake on the floor of the sea, thousands of feet beneath the surface, a place where no lake has any right to exist. This phenomenon is what oceanographers call a deep-sea brine pool, and the most infamous example ever discovered sits in the northern Gulf of Mexico. When researchers first located it, they gave it a name that captures its nature with brutal precision: the Jacuzzi of Despair. While the surrounding deep-sea water sits at a frigid 36 degrees Fahrenheit, the interior of this pool radiates a comparatively warm 66 degrees, giving it an almost inviting thermal glow in the perpetual cold. The visual boundary between the pool and the surrounding ocean is defined by something called a halocline, a sharp, vertical interface where two masses of water with dramatically different salt concentrations meet but refuse to merge. Because the brine inside the pool is packed with dissolved ancient salts, it is far heavier than the surrounding seawater, and the two liquids bend light differently due to their contrasting refractive indices. This creates a spectacular optical phenomenon, where the boundary looks like a liquid mirror, a thick, shimmering curtain that visually warps any object passing through it. When a robotic arm is extended into the pool, it appears to fracture and bend as it crosses the halocline, as though entering a different dimension. The pool has its own internal wave system driven by deep ocean currents passing overhead, and its circular rim is formed by a dark crust of compacted mineral precipitates and ancient organic shells, rising slightly above the surrounding seabed like the retaining wall of a natural stone cauldron. The interior is a deep red-brown, murky and dense, a stark visual contrast to the crystal darkness of the open ocean surrounding it. The scale of brine pools varies enormously across the deep ocean. Some are no larger than small potholes, scattered across the mud like miniature basins. Others are sprawling underwater inland seas of staggering dimensions. The Jacuzzi of Despair itself measures roughly 100 feet in circumference and drops nearly 40 feet deep, forming a near-perfect circular cauldron. But regardless of their size, every brine pool on the planet shares the same haunting characteristic. They maintain an absolute, unyielding separation from the ocean that contains them. They operate according to their own internal fluid dynamics, their own localized temperatures, and their own chemical reality. They are worlds within worlds, governed by ancient forces that have nothing to do with the modern ocean surrounding them. The chemistry inside a brine pool is engineered for annihilation. Any complex organism that crosses the halocline enters a multi-layered death trap that dismantles biological systems at a cellular level almost instantaneously. The first assault comes from the extreme salinity. While standard ocean water carries a salt concentration of roughly 35 parts per thousand, the brine inside the Jacuzzi of Despair reaches concentrations up to 5 times higher. For any marine animal, this imbalance immediately triggers a catastrophic osmotic collapse. Under normal ocean conditions, an animal's internal cellular fluids are carefully balanced against the external salinity of the surrounding water. When a creature crosses into the hypersaline brine, this equilibrium is obliterated in seconds. The extreme external salt concentration begins violently pulling water out of the animal's cells through osmosis, rapidly dehydrating them from the inside. Simultaneously, massive quantities of sodium and chloride ions flood the creature's bloodstream, causing its nervous system to short-circuit chaotically. The brain loses its ability to send signals to the muscles, the heart stutters and stops, and the animal is rendered completely motionless in a matter of seconds. But the salt is only the first layer of the trap. The brine is also saturated with concentrated hydrogen sulfide and dissolved methane gas, both of which rise continuously from deep tectonic fractures far below the seafloor. For any gill-breathing creature, hydrogen sulfide functions as an extraordinarily potent and fast-acting neurotoxin. It binds directly to the iron molecules in hemoglobin, blocking the organism's cells from accessing whatever oxygen might still be present in its body. The result is a form of rapid internal suffocation that occurs even as the creature desperately tries to retreat. Any fish, crab, or other animal that wanders too close to the shoreline or gets caught in one of the pool's internal waves does not simply drown. Its chemistry is systematically dismantled. Its muscles lock into a state of permanent rigor mortis, and it sinks slowly through the thick, dense brine, drifting downward in slow motion like an object falling through heavy syrup, eventually coming to rest on the floor of the cauldron. What happens after death is perhaps the most surreal element of the entire phenomenon. In the open ocean, a dead animal is consumed quickly by an intricate network of scavengers, from large sharks and hagfish to microscopic bacteria, which break down organic matter and return it to the ecosystem within days or weeks. Inside the brine pool, this recycling process is completely impossible. The same hypersaline, anoxic, and chemically hostile conditions that kill complex animals also make it impossible for standard decomposition bacteria to survive. Without oxygen, and saturated in lethal mineral concentrations, the biological enzymes responsible for decay simply cannot function. As a result, every creature that has ever fallen into the pool lies exactly where it landed, perfectly preserved, entirely intact, its shell unbroken, its coloration undimmed, its limbs still frozen in the exact posture it held at the moment of its death. Scientists peering into the depths of the Jacuzzi of Despair through high-definition cameras found thousands of deep-sea crabs, eels, and isopods lying in enormous, undisturbed heaps along the inner slopes of the cauldron. They did not look like skeletons or decaying bodies. They looked as though they had simply stopped moving moments ago, organically pickled in a manner comparable to the mummified pharaohs of ancient Egypt or the preserved bodies found in peat bogs. The pool has constructed an eternal underground museum of death, and every exhibit is in perfect condition. The outer edges of the pool have come to be known as the graveyard rim, a visible ring of preserved bodies, marking the precise boundary where the toxic brine meets the normal ocean. This perimeter, while morbid, also functions as an opportunistic feeding station for a small number of highly specialized creatures. Giant deep-sea isopods and hagfish have learned to patrol the edges of the pool, using their sensory systems to detect the scent of freshly mummified prey. They make rapid, daring plunges into the uppermost layer of the halocline, grab a preserved crab or fish from the rim, and drag it back out into safe water before the brine can claim them too. It is an act of high-stakes ecological theft, conducted at the gates of a chemical underworld and it represents the closest thing to ordinary life that the immediate vicinity of a brine pool ever sees. To understand why these pools exist in the first place, one must travel back more than 150 million years to the Middle Jurassic period, when the supercontinent of Pangaea was tearing itself apart. As the continental plates ground against each other and separated, a massive depression formed between the land masses that would eventually become North America, South America, and Africa. This basin would later evolve into the Gulf of Mexico, but in those early days it was a shallow, landlocked sea trapped under a scorching prehistoric climate. The narrow channels connecting it to the open ocean periodically sealed shut due to tectonic shifts, cutting the basin off from outside water. Under the fierce ancient sun, the isolated seawater evaporated rapidly, and as it did, the dissolved minerals within it grew increasingly concentrated until they could no longer remain liquid. Vast crystalline sheets of solid salt precipitated out of the water and settled onto the basin floor. This cycle of flooding, isolation, and evaporations repeated itself dozens of times over millions of years, each cycle depositing another thick layer of mineral salt until the accumulated deposit measured up to 5 miles thick in certain areas. When the tectonic plates eventually separated enough to allow the deep global ocean to flood the basin permanently, billions of tons of sediment began flowing in from surrounding continents, piling on top of the ancient salt sheet over tens of millions of years. The weight of this accumulating sediment compressed the material beneath it into dense, heavy rock. But solid rock salt behaves differently under extreme pressure than ordinary rock. It is relatively buoyant and responds to compression not by fracturing, but by flowing, slowly and plastically, like a form of geological toothpaste. As the sedimentary weight above grew heavier, the salt layer beneath was squeezed outward and upward, seeking any weakness in the crust above it. It formed massive underground domes, ridges, and pillars that buckled and fractured the overlying rock layers. When these rising salt formations eventually breached the ocean floor, they dissolved on contact with the surrounding seawater, creating dense, hypersaline brine that pooled in the craters and depressions left behind by the collapsing seafloor above them. The Jacuzzi of Despair sits directly over one such salt fault line, where a continuous supply of ancient Jurassic salt is being squeezed up through the earth and dissolved into a self-replenishing basin of poison. The toxic gases that fill the pool arise from the same ancient sedimentary layers, where millions of years of compressed organic matter transformed into methane and hydrogen sulfide under intense heat and pressure, then escaped upward through the salt-fractured conduits to dissolve into the brine above. In 2015, the crew of the research vessel EV Nautilus descended their remotely operated vehicle, Hercules, into the Gulf of Mexico to explore this environment directly. When the cameras caught the shimmering boundary of the pool, the control room went from routine observation to stunned silence within seconds. But studying the pool came with severe risks. The extreme density of the brine created a physical wall of resistance that altered the thruster dynamics of the vehicle, threatening to trap it if it sank too deep. The hydrogen sulfide and methane gases bubbling from the surface were aggressively corrosive, attacking the metallic seals, sensors, and electrical components of the multi-million-dollar machine in real time. The pilots had to maintain perfect hovering precision while fighting internal pool currents, all while knowing that a single thruster failure would send Hercules directly into the anoxic graveyard below. Every second spent collecting temperature data and fluid samples was a calculated gamble against permanent equipment loss. When Hercules finally ascended, the data it carried fundamentally altered the existing scientific understanding of deep-sea environments. The Jacuzzi of Despair is the most famous brine pool, but it is far from the only one. Oceanographers have mapped dozens of these formations across 3 main regions: the Gulf of Mexico, the Mediterranean Sea, and the Red Sea. The Orca Basin in the Gulf of Mexico is the largest on record, stretching 21 kilometers long and 7 kilometers wide. An entire underground inland sea, with nearly 8 times the surrounding ocean's salt concentration. In the Red Sea, the Atlantis Too Deep is heated by active magma chambers to over 150 degrees Fahrenheit, producing a superheated cauldron of pressurized toxic heavy metals. Each pool is unique in its precise chemistry and temperature, but all share the same fundamental architecture of ancient salt, geological pressure, and chemical isolation. The deepest paradox of the brine pool is that, despite being one of the most lethal environments on the planet, they are not entirely devoid of life. Along the thin boundary where the toxic brine begins to bleed into normal seawater, an extraordinary ecosystem has taken root. Chemosynthetic microbes thrive along the edges, feeding on the raw methane and hydrogen sulfide bubbling out of the pool, converting pure chemical energy into biological fuel without any sunlight whatsoever. Dense mats of deep-sea mussels, towering colonies of tube worms, and specialized species of shrimp colonize these perimeters, forming complete ecosystems powered entirely by the very toxins that destroy everything else. This narrow band of bizarre life on the doorstep of absolute death has captured the imagination of astrobiologists worldwide, and for very good reason. When NASA missions return data from the icy moons of Jupiter and Saturn, particularly Europa and Enceladus, they reveal deep, pressurized oceans buried beneath miles of frozen crust. Scientists believe the floors of these alien oceans are fractured by powerful tidal forces and salt tectonics, generating environments that may closely mirror the chemistry, pressure, and temperature ranges found in Earth's own deep-sea brine pools. If microbial life can thrive at the edge of a pitch-black, anoxic cauldron at the bottom of the Gulf of Mexico, drawing energy from chemical reactions alone, then the same process could be operating beneath the ice of distant moons right now. Every time a robotic submersible pushes through a terrestrial halocline, it is not merely exploring a geological oddity. It is rehearsing the methods and refining the instruments that may one day detect life in the oceans of another world. The brine pools of Earth are simultaneously graveyards of the ancient past and blueprints for the future of life across the cosmos.